developer at JetBrains, and I'm here to talk about notebooks. But before we start, quick raise of hands. How many of you have heard about Jupyter Notebooks or used them in the past? Okay, so half of you. So how many are working with Kotlin or have worked with Kotlin in any way? Whoa, okay, that's quite a lot. So how many are only Java developers or have only touched Java? Okay, a few of you. So for those guys, I hope that convinced you to give Kotlin a second try after this. So let's get started. So Jupyter Notebooks, for those of you that haven't heard about it before, is basically this interactive playground that allows you to mix documentation with code. And what makes it special is that you can also execute that code directly within this notebook environment. So that means that you can sort of have this mix of documentation, code, output, and then just iterate from there. And that is, of course, useful in a number of use cases, like if you are doing documentation, if you're prototyping, especially in data analytics. Is it very common to use notebooks for this? But what many don't know is that notebooks are actually a very generic architecture. So while it's commonly most seen in the Python ecosystem, you can actually replace the code engine. So that's what we've been doing with Kotlin, where we basically replaced the engine with a Kotlin compiler. So that means that now you can actually write Kotlin code in here. So of course, this is just the first step. So while what we see here on the screen is basically the standard web UI that is just running in a browser, what makes it more interesting is that we can also move this into the IDE. So what we also did was that we created an IntelliJ plugin that basically moves the entire notebook experience inside the IDE. And that has the advantage that then suddenly you get all of the nice IDE features, like you get highlighting, you get completion, you get jump to definitions, refactoring, all of those things you are normally used to from a normal IDE experience. You can also get that with notebooks. But then how does it actually work? So notebooks are basically built from what we call cells. So that is like the building block, and then a cell can either be a markdown, which is just rendered as markdown as we see here, or it can be code. And those code cells you can write like code as you would normally write it. So as if you do it like in a top-level file, or if you do it inside a function body, that is the kind of code you can write here. So in this case, like we're just creating a variable, then we compile the cell turns green, everything is fine, like we compile it. But of course, there's nothing really interesting here, right? It's just code that doesn't do anything. But then what makes notebooks interesting are that suddenly this variable is then exposed to the rest of the notebook. So now, because you are inside an IDE that has the type system, it can now autocomplete into those variables you defined just above. So now here we know the type, and we can just call it. And then when you trigger it in here, you now get the output of the previous cell. And of course, this is just normal, like how you would expect code to work. You declare a variable, you call it, it returns the value. Like that's normal. So what makes this interesting? So where notebooks differ from normal code is that you can actually redeclare the variables or language constructs you just defined. So like this works with variables, where you can redeclare not only the type, but also the value. And then when you call it again, it will actually return the new one. So that, of course, means this is a really great way to sort of gradually experiment, build up your like function, your class, whatever. You can basically just recompile the same cell over and over. And then once you're happy, then the rest of the notebook only sees the final result. And of course, this also works with functions and everything else. So what makes notebooks even more interesting is that they have this concept of output, right? And up until now, we just saw only text output. But because notebooks are like a complete engine, you can actually intercept this output and do other things with it. So we have this concept of custom renderers, which basically means that if a notebook knows a certain output is of a certain type, can do things with it. So in this case, we have a helper method that is basically treating anything it gets as HTML. So when we run that, you can actually display that as you would do it on a website. And this works with a number of different outputs. So we have HTML here. It also works with like images. So let's say you have a normal Java buffered image you are reading from somewhere. If you output this, suddenly you get the image within the notebook. And we ship with a number of like default of these renderers, but of course you can also create your own if you have your own specialized data types you want to do something with. Like you can also actually do extra things with it and make sure that they are rendered in a way that makes them nice to look at, basically. Of course, this is just the basic building blocks of notebooks. So in order to sort of, what can we then do with it? It's probably easier to talk from use cases. So in here, I sort of created a use case. So let's say I'm a speaker here at Øredev, which surprising I am, or I'm a conference organizer that wants to sort of make sure that, okay, are we biased in any way with how the sessions we accept, or like if I want to have a talk for next year, is there something I have to be aware of? Like how can I use notebooks to sort of explore that use case? So the first thing I did for this was that I went to the Øredev website, I looked at the HTML output, and I noticed, oh, they have this nice REST API. So they have a URL that returns all the sessions. So let's try to see if we can get that into notebooks and do some analysis on it. So the first thing we do for this is that we have to understand that notebooks are, because they're this framework, they have this concept of integrations. So basically, there is an API that basically allows you to wrap any Maven dependency you have within this API. Then you can add helper classes, helper methods on top of it, as well as adding specialized renderers. So in this case, we have a number of integrations already shipping with the plugin for the most common use cases. But in this case, like we're looking for a REST client, right? So since we're in Kotlin, we have Ktor, which is a pretty common one. There's integration for that, so let's use this. So we include it, compile it, it's now available. And what that does is it basically adds helper methods to the next cells. So in this case, it exposes this HTTP variable, where we can see here it actually contains the client, but it also contains like helper methods to just easily call get methods or whatever on the network. So let's try to do this. So we try to run against the URL we found on the website, and we can see, okay, it returns okay, fine. At least it works, that's nice. So let's try to read the text. So that's what we do here. And then we see another advantage here, right? Because this integration knows that if it sees JSON, it can actually format it nicely. So that's what it's doing here. It's basically just presenting the JSON output as something that is much more readable and easy to like figure out what's going on. Of course, like anyone that is working with JSON within the JVM ecosystem, we know JSON is a really annoying thing because it's normally you just see it as an unstructured hash map, which is like then you have to manipulate strings or whatever. Like it's super annoying to work with. So this is again where notebooks can help because we are allowed in these integrations to run code between cells. We can actually tell the notebook that if you see JSON, you can, instead of just giving a hash map back or like a JSON element or whatever like normal APIs we have, it can read that JSON, turn it into a type hierarchy, and then replace the variable you had with that type hierarchy. So that's basically what this method here is doing, deserialize JSON. It is basically telling the notebook, if this is JSON, turn it into a types. So when we print it again, it looks the same as before, but on the next cell, now suddenly you can actually access the JSON as you would like you had the types themselves. So and of course this makes it a lot easier to sort of navigate, at least if it's a new API, like you can explore, it's a lot easier to sort of dig into it and figure out what's going on there. And in this case, right, we can see that it completely matches the JSON structure above. It was an array, sure, so we can get the first element, and then we have the sessions and the group names and all of these things available directly. So when we call the group name, it actually returns the all value from the JSON structure. So now we have the data. What do we then do with it? So the first step we do here is that we pull in more integrations. So in this case, we're pulling in integrations for data analytics, which is called Dataframe and Kandy. So those of you that know Python, you probably know pandas, which is like the same concept, just for Kotlin. And for those that don't, like data frames is basically like an Excel sheet kind of API. You can put anything in, and then you can manipulate it really easily. And Kandy is a visualization library to like make graphs of it. So we pull those in, nothing happens, they're just there. But what they do, they add even more helper methods. So in this case, they make it easy to convert any class you have into a data frame. So we can basically just call this extension method to data frame on the sessions. And now we have all our session data in this data frame where we can more easily work with them. So in this case, there's a lot of stuff in here we don't really care about. So we need to extract that out. So that's what we do here, where we basically take one data frame and map it to the other. And this is where, again, we see the advantage of being inside a type-safe language, right? Because you can see the title and description are the categories. they all point to variables. Those variables were actually automatically created because it could see in the data frame that those were the column names. So now they get turned into a variable you can access, and you have autocomplete, and you can like see the types of them directly there, right? So this is where the IDE experience can really help you doing stuff like this, which is if you did this in Python, like you would basically have to do all of the string-based APIs and then trust that the type somehow was correct at the end. So in this case, now we sort of extracted the data and see, okay, now we sort of where we can start to work with it. And here we, of course, notice, oh, it's actually not only sessions in this API, they also have their breaks and like all the stuff around the sessions, they're inside here. So we should probably like remove them somehow. And this is where data frames are nice because they're just an in-memory data structure. So we can just filter those out. So that's what we do here. And now we are sort of back down to like, okay, this is the data we actually want to do stuff with. So here we'll then, okay, expand it with metadata we can sort of analyze on. So the first thing we want to do is we want to expand it with the length of the descriptions because we have a hypothesis that maybe there is something with how long your abstract is depends on what if you get accepted or not. So we do that here, which we can just do dynamically here, and then it becomes available immediately. And you can see here on the right side that now we can see, okay, at least on the surface, it looks like there's a pretty big range of how long the descriptions are. And because we have these customized outputs, these data frames are actually like small UI blocks in themselves. So they also have ways where you can just, like you can see the small arrows on top, like that allows you to basically just like do simple things like sorting directly within the UI if you didn't want to write the code to do that. Then we want to look at more metadata. In this case, we want to extract what is called the Lix number, here, at least here in the Nordics. That is called the readability index, which is sort of like a ratio between how long a text is and how many long words there are. So basically, the higher that number is, it's like the idea is that the more tricky it is to read this text, right? So we have an idea that, okay, maybe if you have a very complex abstract, it won't get accepted, but we'll find out. So, and this is where we get another advantage of being inside an IDE, because in this case, this Lix method of calculating this number is, of course, just like a helper method somewhere. We could have written it inside the notebook and just used it there, but maybe we had a project where that calculation already existed. So by virtue of being inside the IDE, we can actually access the project we're in. So that's what we're doing here. We're basically saying that this notebook, if you're inside a project, you have access to my entire project code. This is, of course, extremely valuable if you're trying to document a library or your project itself. Then instead of you having to duplicate a lot of code, you can basically just point to the code you have and say, you run it like this, here's the output of how it runs, and it will continue to working and evolve along your code base rather than being something next to it. So, yeah, and we can see here, right, so it just lives in the project and we can reference it as it would be inside the notebook. So we did that, and now we have like those numbers as well, and we can see they're also a bit all over the place. So for those who don't know, like anything below 25 is normally like very easy to read, like children's work, and anything above about 50, 55 is sort of like, that's very normally seen as very hard to read. So there are definitely some things to look at here. So of course, at this point, we have a lot of metadata. We will try to figure out what's in it, right? So the easiest thing is, of course, just printing, like trying to find the minimum and maximum of these values, which you can do with these kind of helper methods, where we just extract them and print them. And this is where we see another notebook feature, where normally up until now, we've seen only the last statement being printed as output. Using these display methods, you can actually display more things from each cell, or like, which is, for example, helpful if you have some kind of loop and you want to extract something from within the loop or things like this, right? So we can print this, and suddenly we have a better understanding of what this data is. And of course, this doesn't tell us that much, except that there is actually a very wide range. For some reason, of course, like a talk about hello world is probably okay. That might make sense that isn't hard to read. Whereas apparently architects like to use a lot of big words, which I guess makes sense. And the keynote are apparently, they don't have to write much of an abstract, probably because they got invited anyway. So of course, that kind of data isn't like just having text as trying to figure out what is going on there is of course hard for us humans to like figure out. So it's a lot easier if we can visualize it. So this is where we bring in Kandy, which basically allows you to jump from any data frame into visualization APIs really easily. So we have these plot helper methods that then basically allows you to define the kind of plot you want on the underlying data frame. So in this case, we want a box plot, which tells you something about the distribution of the data. And again, we see here the advantage of being in a type-safe language, because the Kandy also understands these type-safe accessors to the columns in the data frame. So instead of us having to remember what the columns were, we can actually autocomplete into them and make sure that the types are correct again. When we run that code, suddenly we have a visualization inside our notebook. And of course, through this, like we're sort of exploring the data, right? And we can just change the visualization if we want to, or we can continue from here. In this case, it tells us something about the data, right? It tells us, okay, it looks like looks like a big range of how difficult the texts are to read. So probably that's fine. It looks like the off track is definitely trending higher, which I guess if any of you have seen the off track talks, like that's probably for a reason. Like they're extremely, like at least the abstracts are extremely complicated compared to the rest, so that probably makes sense. But at least now we have something that is easier to talk about. We have data we can look at, and it's easier to ask these kind of questions. So we do the same thing with the length, where we create a new plot. The same thing, try to visualize that, and see, oh, okay, it looks like if you want to have an abstract accepted at Øredev, you probably have to do something around 500-700-ish characters. At least that will probably increase your chances, which I guess is nice to know. But apparently, if you are writing a talk about testing, like for some reason they like to use more words. Maybe that's a consequence of just the talks were that good, or maybe it's a consequence of the reviewers being biased. We don't know, but at least now we have something concrete we can like ask those questions from, right? So the next thing we want to look at is let's see how, like we have three different kind of tracks at Øredev, right? There's the intermediate one, or the introductory ones, there's the intermediate ones, and the advanced ones. So let's see if we can see if there is some sort of structure to this. So we started by grouping by the tracks, which basically gives us these subgroup data frames. We want to, and inside each of those, we sort of now can see how they sort of differ. Of course, that kind of structure here is pretty hard to visualize, so we need to like map it to something else. Now, so at least if you're used to data analytics, like basically you are pivoting a table and extracting some things to get into a format that is nicer to visualize, which is what we do here. And suddenly now we can see for each track how many of each level got accepted. And of course, again, having it in a data frame is of course nice for the first sort of just grasp of the data, but visualizing it is much nicer. So that's what we do here with a box plot, or sorry, with a grouped bar chart. Where again, just having it visualized within the notebook makes it easy to sort of see immediately where, like, are there anything here that is interesting? And of course, the thing that jumps out immediately is that apparently there is quite a lot of intermediate talks. So is that an accident? Is it by design? We don't know, but at least now there is something we can ask those questions from, right? And for example, on the JVM track like this one, we don't have any advanced talks for some reason. I guess we don't know, but like at least that at least points to that if you want to have a talk here next year, like you probably shouldn't make an advanced talk. So at this point, we might be happy with our analysis, right? So we say, okay, we're kind of done. What do we do with it, right? Of course, we just ran all of this locally, which is great. But now, how do we share it with other people? And one of those ways you can do that is, let's say we had a database where we wanted to store this kind of thing. In this case, we can do it with another integration, in this case, the database integration, which basically just exposes a JDBC connection to any kind of database. So this integration basically just supports the most common JDBC drivers. And especially for a presentation like this, having SQLite is nice because they have an in-memory mode, so you don't have to have a server running. But of course, you can point this JDBC URL to like whatever hosted database you had if you wanted to do that. And once we create that, we have this Hikaru data source. And at least if you're a backend developer, like these are the kind of concepts that you put into any kind of database layer you normally have. So that sort of allows you to do whatever you want with it from here. And this is, of course, now we sort of jump into one of the problems with being a generic plugin is that, so when we worked on this database API, we sort of had the assumption, oh, like databases are a solved concept on the backend, which it kind of is, but it turns out that no team agrees on which database they want to use. Everyone has their favorites, so it means that we have a hard time figuring out, okay, what do we want to support inside this notebook? So in this case, we're basically leaving it up to you guys to bring in your own database dependencies. And this shows another feature of notebooks, where basically if you, whatever database API you have, it's probably in Maven somewhere, then you can just depend on it through this and then have it being available. Or you could use if you are documenting a project, you probably have some sort of database APIs in there, and then you can just depend on those, right? But in this case, we also see that those lines here are red. And you might wonder why, because like I'm just including the dependency here, so it should know those types. And that is because as long as you are working within a single cell, like that code hasn't been executed yet. So of course, in this case, like even though a compiler might accept this as valid, like the IDE doesn't. So if you wanted to avoid these red lines, you would have to like sort of include the dependencies in a single cell, execute that, and then the rest of the notebook would know those types. In this case, it doesn't. But once we compile it, it compiles fine anyway. And now we have this JDBC template, which is basically just your normal database client. And then we can use that as you would use normally in your code. So in this case, of course, it's an in-memory database, so it doesn't have any tables. We need to create that first, and then we can just batch update it with the data we found in the data frame. And that works. And then we can also read the data out. Like, for example, in this case, we saw that we pulled the data from a REST API, but maybe you were sort of analyzing benchmark data from a database. Maybe you had some metrics that lived in your database anyway. So you could just read that out instead of going through a REST API. So like, of course, you can just use the database client for this, where it will read it out again, and it will also display fine. Like that, because we try to sort of make these notebooks, they should try to integrate these concepts nicely across boundaries. So normally you would see like it's easy to go from database or from data frames to plots, and the same thing from REST to data frames, right? So we do the same thing with databases, where like if you don't want to like try to figure out what database client you need to use and stuff like this, and you just want to read a single table from your database, like there are shorthands for this, which is basically what we do here, where we just go directly from a database connection, where we just say this is the table we want to read, and then it just reads it into the data frame, like here, right? So there's all these shorthands that should hopefully make it easy to sort of jump between domains and make sure that you can work with the data in the way that you like, basically. So another approach to sharing these notebooks is also, because notebook files, they are just a file on the file system. So like you could just, like at least in a project, you can just store that notebook inside the project, share it, and it's just available in your project, and you open it, and everything works fine. But because Jupyter Notebook is this standard technology, other services also support them. So in specifically GitHub, they have a custom renderer for these kind of notebooks that doesn't depend on the language. So inside our plugin, we have an easy way to sort of just share it to GitHub. Of course, if your project is on GitHub, like your files get shared, that this works without you having to do this. But let's say you wanted to share a notebook with an audience outside your project. In this case, you can export it as a gist, which will basically take the entire notebook, turn it into a gist, and then you have it on GitHub. And here we basically see the same nice UI that you saw in the IDE, which of course, if you are writing documentation, if you are writing a tutorial, if you want to do or have visualizations that sort of, oh, this is what I found, this is my conclusion. Having all of that displayed nicely on GitHub just makes it very easy to sort of share those findings. And of course, you could just download this. This is a notebook file. You could download it and open it inside the plugin and continue to work in it if you wanted to. So that was sort of like one use case at least, but there are also others. And some of those require that we know a little more about the notebook architecture in general. So if we take a step back and look at that. So this is how Jupyter Notebook generally work, is that there are three different layers. There is the UI or the browser, then you have a server that is sort of handling the file interaction, and then you have these kernels that is basically responsible for compiling the code. And all of these are neatly separated in layers, and there are communication channels between them. The problem, of course, is that that means that if you have some sort of code that has complicated output, that is really hard to serialize. You have a problem. Because how do you turn, for example, a UI element into something you could serialize into a HTTP request and deserialize it again and make sure it works, right? That is sometimes possible. In many cases, it's just impossible. So that means that in this kind of architecture, there are use cases you can't even support in notebooks. And this is where living inside the IDE also brings advantages, because we basically, while we have this architecture, it also allows us to break down these boundaries. So the first thing we did was that basically when you open a notebook, we run in what is called this mode, where we basically joined the server and the view into one. So there's just a lightweight server that talks to a kernel. This is of course nice because then that separates, it's better for isolation. So anything you compile so if it crashes, it's not crashing the IDE process. You don't have issues with the class path being weird and stuff like this, right? So having that sort of as a default behavior is kind of nice. But it also allows us to completely remove those boundaries. So in the notebook plugin, we basically allow you to choose a run mode, which is either a separate process or the IDE process. And if you run inside the IDE process, basically everything here runs inside that one. So that means that the compiler runs there, and the UI runs there. That has the advantage that, let's say you are trying to explore a UI framework, and you get something out of it. Instead of us having to figure out how to serialize it, we can just take it directly from the compiler, put it into the UI, and then hope that the UI knows how to render this thing. And this, of course, in many cases requires a custom rendering, but at least it's possible. So in this case, for example, we choose it up here, where we can choose the IDE process. And then suddenly it allows us to work with things that you normally can't in notebooks. In this case, let's say we're working on a Swing application, and we want to try to figure out how this UI should look like. And normally if you do this, you have to basically keep rerunning some code, which is pretty annoying. But inside a notebook, that feedback loop is extremely fast. So in this case, we basically created a small color selector. Let's try to run that, and suddenly we can see that can actually be shown directly within the notebook. And because we didn't have to serialize this UI component, it actually works completely as we defined. So when these on-click listeners we added also works as we would expect, right? And this also running inside the IDE process. So this is one that is a use case that is more generally useful. But if let's say if you're running inside IntelliJ and you are working on IntelliJ plugins themselves, suddenly you also have access to all of these plugin APIs, and you can sort of experiment with creating a plugin yourself within the notebook, and without you having to basically reinstall a plugin all the time. So that sort of brings us to a number of use cases we've seen, right? So, and at least from what we can see, notebooks, they are useful in a lot of cases. The most common ones we've seen are the ones I added here. So if you want to document a library, it's very useful because you can match or mix text with saying this is how the library works, and people can then actually see the code and how it runs. That is very useful. We have seen people using it as sort of a Postman Lite client, where instead of you having to maintain a Postman collection on the side, suddenly you can have all of these use your REST APIs inside the project itself. It will evolve alongside them, and it's very easy for people to trigger them, and you can customize how you want to describe people using this. Not right now. So no, not right now. But of course, it will if you run it, it will fail, right? So And of course, prototyping new features is like where it's immediately obvious that it's useful, because like you don't have to wait for like a big compilation process. You're only compiling small snippets at the time, which makes it a lot faster. And the use case we just saw is, of course, immediately useful, like where you are analyzing things and you want to visualize them and somehow get a grasp of it. And the last use case is one we have definitely seen where people are adopting it, is for like script replacement. Like if, let's say, you are a product manager and once a month you are running some analysis on your Jira tickets or whatever issue database you have, you don't want to have that. You don't want to set up a Grafana pipeline. You're just doing some basic things yourself. Then having it inside these notebooks makes it very easy to do that in a structured way. You write this once, you can just run it like when you feel for it and make sure it actually do the same thing every time. And especially if you are normally used to working with the Kotlin code, like you don't have to jump domain. So like because what people normally do here, either they have to jump to writing a Bash script, you have to write a Ruby script or a Python script or whatever, and just jumping languages can be annoying. So being able to stay within the JVM ecosystem has a lot of value in this case. So how do we get started with notebooks? Right now, they are included by default in IntelliJ, both in the community and Ultimate. So when you have the welcome screen, they're basically immediately available. You can either create them there, where they will live outside any projects you have, which can be useful. If you're inside a project, like you can basically create them as any file you want and just have them there. Or if you're in Android Studio, they are not included by default, but they can run, but you just need to install the plugin there. So I think that was more or less it. So there is this QR code. So the code and the notebook itself is on GitHub, so you can find it there. We do have docs for all of these things, which there's also a link to. The kernel itself is open source, so there's also a link to it here. That repository also contains information about how you write your own library integrations, if that's what you want. We do maintain like a list of the most common ones, so if you create one you think is more useful to others, like you can also contribute to that. I think one of the biggest issues we see with people adopting notebooks is that unless you are used to data analysis, getting used to data frames and Kandy and those kind of libraries is tricky. Like it's not a way of working with data you're normally used to. So we do have a lot of examples around this. So you can sort of start from an example. Like we mentioned this long list of Kandy examples. So if you know, okay, I want a graph that looks like this, you can find an example and then sort of figure out how you write your own code to sort of match that. I think that was it. So thank you, everyone. And I think we have time for questions if there's.